Hi, my name is Joe, and thank you for checking out my story about Victor the free body diagram. Victor here has a pretty crazy life, as physicists are pretty much always using him to decide, in their heads at least, how a specific object is going to behave when certain forces are directed at it, on it. If there are no forces applied in any direction, or they're equal forces applied in opposing directions, then Victor's in what we call a state of equilibrium. There may be forces acting on him, there may be no forces acting on him, but in either case the net force, the resultant force, is zero. Therefore, nothing's happening. There's no acceleration. Victor's not changing what he's doing. If he's flying off at a straight line, he's going to continue to do so. However, if we begin to apply a force in one direction, and only one direction, unopposed, then things start to happen. If Victor starts at rest, and we apply a direction, or a force, excuse me, in the upward direction, Victor's going to move up. Up he goes. And that's pretty much the same for every single direction. From a state of rest, if I apply a force in the right direction, the down direction, or the left direction, Victor is going to move that way accordingly. Now, what we're going to attempt to figure out is what will happen to Victor if we apply multiple forces at the same time, but not necessarily equal and opposing forces. See, we don't want to reach a state of equilibrium like we mentioned before, so we're going to apply two equal forces in the up and the right directions. We're going to consider these forces the sides of a triangle, and then we're going to redraw them tip to tail so that the direction of the resultant vector is more obvious. Now that we have our triangle set up like this, we can see that we have the right angle. We've redrawn our upward vector at the opposite end of our right vector, but the line that goes up at an angle between the two is our resultant vector, and it's actually pointing in the correct direction for the free body diagram, Victor. Now we need to go ahead and label our sides, and once we label our sides, we can apply a couple relatively well-known mathematical constructs and, see about getting an actual value for our resultant vector. So here our resultant vector is labeled as C, and we're going to use Pythagorean theorem in order to see what C is. So C is equal to the square root of a squared plus b squared, which means that if a and b were both equal to 2, C would be equal to the square root of 8. Now, we probably want to know the direction in terms of degrees of the resultant vector. So what we can do here is we can use trigonometric functions. In this case, we're going to use sine to say that the sine of angle AC is equal to B over C, which is the same as saying angle AC is equal to the arc sine, or sine inverse, of B divided by C. In this case, 2 divided by the square root of 8 ends up being about 0.7, something like that. If you take the inverse sine of that, you're going to find the angle to be about 45 degrees, which makes sense because we all know that if we have 2 equal legs of the triangle, the 2 extra angles in the triangle are going to each be 45 degrees. This is going to leave us with one resultant vector composed of the 2 vectors that we had initially added. It's going to be at 45 degrees above the horizontal, and it is going to be of magnitude the square root of 8. Anyway, I hope you had fun learning how to decide how Victor was going to react in the presence of 2 forces. These steps can be applied to virtually any 2 vector forces. Thanks again. Have a great day.